All right, today we're going to talk about one of the unsung heroes of any network, the Layer 2 switch. We're going to pull back the curtain and really deconstruct it, from how it actually thinks to how we can get in there and command it to build faster, smarter, and more secure networks. Okay, let's just dive right in. Now, I know what you're thinking when you see a diagram like this. It looks kind of complicated, right? You've got servers, IP phones, workstations, all funneling into this one device. But stick with me, because by the end of this, every single line and label on this blueprint is going to make perfect sense. You'll see exactly how this thing works its magic. So let's start with the most basic question of all. What makes a switch smart? How does it know where to send data instead of just shouting it out to everyone connected? We're going to find its brain.
Yeah, that's really the heart of it, isn't it? How does this box think? It might seem like magic, but it's not. It's actually a remarkably elegant and simple process. And for any network engineer, this is something you've got to know inside and out.
And here it is, the secret sauce, the MAC address table. You'll also hear tech folks call this a CAM table. Just think of it as the switch's personal address book. It keeps a running list of every single device's unique hardware ID, that's the MAC address, and which physical port it's plugged into. This table, this is the entire foundation for how a switch makes its decisions.
So how does that address book get filled out? Well, it's a constant two-step dance. Step 1, the switch learns. When a frame of data comes in, the switch peeks at the source MAC address and thinks, aha, so that's who lives on port 5, and it jots down that MAC to port mapping in its table. Step 2, it forwards. The switch looks at the destination MAC address. If it finds that address in its table, it sends the frame only to that specific port. Super efficient. And if the destination is a total mystery, well, it does the only thing it can. It floods the frame out of every other port, kind of like shouting into a crowd and hoping the right person hears you.
And even that forwarding step has a choice. It's the classic trade-off. Do you want to be fast or do you want to be careful? The default on most Cisco gear is store and forward. Think of it like a meticulous mail sorter. It takes the whole packet, checks it for errors, and then sends it along. It's safe, it's reliable. The alternative is cut-through. This one's the speed demon. It just glances at the destination address and bam, it's on its way. It's way faster, but you do run the risk of forwarding a corrupted packet now and then.
Okay, so we get how a switch thinks. Now, how do we use that knowledge to our advantage? Because in any big network, things can get chaotic pretty fast. And that, my friends, is where VLANs come in to save the day.
Imagine a network is just one giant open-plan office. If one person shouts out an announcement, a broadcast, everyone has to stop what they're doing and listen. In networking, we call that a single broadcast domain. It's noisy, it's inefficient, it's a potential security mess, and it just does not scale well at all. So, we fixed this mess with VLANs. A VLAN, or virtual LAN, is pure genius. It lets us take one single physical switch and, through software, slice it up into multiple, smaller, completely isolated virtual switches. Each VLAN becomes its own private little world, its own separate broadcast domain. And this is what it looks like in practice. See, we haven't added any new hardware, but this one switch now acts like it's 3 separate devices. The sales and VoIP traffic is totally invisible to the engineering and dev teams, and vice versa. It's like we've built soundproof virtual walls right inside the switch, which is a huge boost for both performance and security. So the theory is great, right? But we're engineers. We need to know how to actually build this. So let's pop open the command line and get our hands dirty.
Creating a VLAN is actually super simple. First, you just create the container for it. You type VLAN 20 and poof, it exists. Now here's a pro tip. As a best practice, immediately give it a descriptive name, like name student. It'll make your life so much easier down the road. And of course, save your configuration.
Okay, so the VLAN exists, but it's empty. Now we have to actually put a port into it. You just hop into the specific interface you want, let's say Fast Ethernet 06. Then you tell it to be an access port, which just means it's dedicated to one single VLAN. And finally, you assign it, Switch Port Access VLAN 20. Done. Any computer you plug into that port is now on the student network.
Now, here's a scenario you will see all the time in the real world. VoIP phones. The phone often sits on the desk, and the user's PC plugs into the back of the phone. So how do you handle that? You want the phone's traffic on a high-priority voice VLAN and the PC's data on a normal data VLAN. Well, you can configure a single port to handle both. You just define a special switch port voice VLAN. It's like creating a carpool lane for voice traffic on the same physical road.
Once you're configured, maintenance is everything. You are going to live and breathe the show VLAN brief command to check on your setup. But listen up, because this is a huge gotcha. Before you ever delete a VLAN, you absolutely must reassign its ports to a different VLAN first. If you don't, those ports become orphaned. They're inactive, they can't communicate, they're just dead in the water until you manually fix them. Trust me, you don't want to learn that lesson the hard way.
Okay, awesome. We have now mastered slicing and dicing a single switch. But what happens when your network gets bigger than one box? How do you stretch these VLANs across an entire building or campus?
This is the next big challenge, right? You've got your student VLAN on the switch on the first floor, and you've got more students on the switch on the third floor. You need them to talk to each other like they're in the same room. But you can't just run a new cable for every single VLAN. That would be a cabling nightmare. So, what do?
The solution is a trunk port. A trunk is basically a special high-speed link between two switches that acts like a multi-lane highway. It's designed to carry the traffic for all of your different VLANs at the same time, all over one single physical link.
So how does this highway know which car belongs in which lane? The magic here is a protocol called 802.1q. As a frame gets ready to leave one switch and cross that trunk, the switch inserts a tiny little digital tag into its header. That tag is simply the VLAN number. When the frame gets to the other switch, that switch reads the tag and knows exactly which VLAN to deliver it to. Simple, but absolutely brilliant.
And configuring a trunk is pretty easy. The main command is switch port mode trunk. But, and this is important, the next two commands are absolutely critical for security. You always want to change the native VLAN to something unused to prevent certain attacks. And then you use the allowed VLAN command to prune the trunk. This lets you explicitly say which VLANs are even allowed to cross, which stops a bunch of unnecessary traffic from clogging up your main network links.
And of course, always verify your work. The command show interfaces switch port is your best friend. It gives you a super detailed report, and you can see right there, yep, it's in trunking mode, it's using the right .1q standard, and you can see the native and allowed VLANs you set. This is your proof that your multi-lane highway is officially open for business.
Wow, okay, we have covered a ton of ground. We've gone from the switch's basic decision loop all the way to scaling networks with trunks. Now, let's just boil all of this down into a single practical cheat sheet that you can actually use. And here you go. Consider this your administrator's cheat sheet. Here are the must-know essential commands for those three core tasks we covered: creating a VLAN, assigning ports for both data and voice, and setting up a secure trunk link. This is your quick reference card for building clean, segmented, and scalable Layer 2 networks.
So, there it is. We've deconstructed that complicated blueprint. We put the core command line tools right in your hands. You now understand the fundamental logic of switching, segmentation, and scalability at Layer 2. The blueprint is yours, the tools are in your hands, the only question left is, what are you going to build?